All right, welcome students, and before we get started, make sure that you have your notes printed out from the section entitled Atomic Structure. We will be spending a week and a half, 2 weeks talking about basic atomic structure. Some of this should be review, some of this should be stuff that you've heard in other science classes and be familiar with, and some of it might be a little bit new. We will be going in to a little bit more depth. Along the way here, we will be actually connecting and have some links to other YouTube videos, so be prepared, and those are just kind of visual examples, so be ready for that. Basically, what we're going to deal with is in chemistry, we deal with the atom. That is the kind of basic, that's the smallest particle of an element, and since elements compose all of matter, how do we discover the atom? What is the atom? What is it made of? How did we discover what it's made of? All of those kind of questions we're going to answer today, and some of this is going to lead and lay the foundation for future things such as bonding and chemical bonding. So we're going to start with kind of the history of basic atomic models. In other words, where did we even come up with the concept of an atom? Bear in mind that nobody has ever seen an atom. They're too small, even with the most powerful microscopes that we have today. Nobody's actually seen one. So what we develop is what's called a model, which is a working representation of experimental facts or a conceptual image. And this is really what you do in science, is you develop models that fit the facts, that are based on certain things that you've observed or that you've seen as you go through the scientific method. And so you'll see there's a number of different models over the years of atoms. And they've changed because we've learned new things about atoms. So we're going to start with the first guy. The first guy is Democritus, and he was before Christ, about 400 years before Christ, and he was a Greek philosopher. And he is the first one to say anything about an atom, really. And he kind of came up with the idea that matter is made up of separate particles. It is not all just one big continuous thing. It is made up of separate particles. And he felt that you could divide those separate particles down to a point that it was indivisible. In other words, you could get to a particle that you could not divide any longer. At that point, you couldn't divide it anymore without it losing its properties. In other words, you could not just keep infinitely dividing it. And so he called that smallest particle the atomos. And that's where we get our name, the atom, from. So Democritus is kind of responsible for the concept of the atom. Now, a couple thousand years went by before really we developed that idea any further. And that's about as far as it went, partly due to limits of technology and a variety of other things. But that's kind of where it started with Democritus. The next guy that comes along is a guy by the name of John Dalton, and Dalton would be in the 1700s and 1800s, and he is considered to be the father of the modern atomic theory. That might be worth knowing, is his title. And there, by this point in time, the scientific revolution had begun, and he concluded through experimentation that atoms of different elements form compounds, which was a new idea. Before it was kind of matter is matter is matter, and one piece of matter is the same as other pieces of matter. And he was really the one to come along and say, no, that's not the case. You have these different elements that we're starting to discover, and if you combine them in certain ways, they would form different compounds. And each compound has its unique ratio of elements that are combined together. Now, did they understand how they were combined together or the concept of chemical reactions and bonding? Not really at this point, but he was the first to state that. And there were a couple key things that he did say that were basically correct. One is atoms of different elements have different masses, which we now know to be completely true and accurate. Every element has a different mass. And the second key thing that he said was an element or an atom of an element can't be changed into an atom of another element. So if you start off with iron, it will always be iron. You can't change it into another element. And he did say some other things along the way as well, but we're going to kind of key in on those two. So he started us kind of in the right direction of what is an atom and how does it function as we understand today. All right, the next guy that we're going to get to here is Thomson, J.J. Thomson. And each one of these guys, you kind of want to know what they contributed to science and chemistry and the discovery of the atom. That will be super important. So you have Democritus with, discovering the concept of the atom, or developing the concept of the atom. Thomson's going to discover something very unique. Dalton basically had said that, well, okay, you have atoms and they're unique. A hydrogen atom is smaller than an oxygen atom, and one weighs more than the other. But an atom is still an atom, and there's it's just this big indivisible sphere. Well, Thomson's going to come along and kind of debunk that. And he started with the cathode ray tube experiment. So we're going to watch kind of briefly what he did. So hang on here and we'll see what is going on.
Okay, this is a cathode ray tube. What essentially is a battery tube. There are no gases inside this glass tube. Everything we have are two electrodes, one is called cathode, and the rest is screen. And the background is called with some type of fluorescent material. When you turn the power supply on, the city of beam is the causes pulse flow. So you actually take pulse. You pull it because it actually cathode shoots across the screen. Essentially,
All right, I just wanted you guys to see that so you could visualize what the cathode ray tube experiment was and what was going on. You had this cathode ray tube, and he shot a beam of electricity, and as he tested it with magnets and magnetic fields, he saw that the beam would bend. And out of that, in multiple experiments, he came to a conclusion that, wait a minute, there must be something to this. There must be something causing this. And basically the idea was, okay, whenever I put a negative end of the magnet, okay, we would call it sometimes north and south, but you can also do it as positive and negative. The negative end of the magnet to the light, it is repelled. And when I put the positive end of the magnet to the light, it's attracted. So what does that tell me? Well, we should know that opposites do what in science? That's right, opposites attract and likes repel. And so he came to the conclusion that whatever this is made up of, it must be made up of particles that are negatively charged, because whenever you put a negative magnetic field near it, it repels. And if you put a positive magnetic field, it attracts. And so he discovered that there were tiny particles that could be separated from the atom, which had a negative charge, which was different. So now the atom can be separated. It's made up of some particles. And so he came up with what's called the plum pudding model. And you kind of see an example of the idea here. And so he thought the atom was kind of this sphere of this goop, and this goop was positive, and then embedded in this goop, as you can kind of see, there's little nuts or raisins or whatever embedded there. Embedded in this goop are all these electrons, which are negative, and the negatives cancel out the positive, and the positive goop cancels out the negative. So overall, it's neutral, but under the right conditions, those negative particles can be shot out of the electron. So he was the first to really discover what we call the electron, the first particle that was discovered in the atom. Now, was his model completely correct? No. but he was onto something to begin with. So now we're going to move on a little bit further. And his is sometimes referred to as the plum pudding model. You will want to know what each model is often referenced to or called. So he was the plum pudding model. The next guy that we have is Rutherford. And Rutherford, he did what's kind of an experiment called the alpha particle experiment. We're going to watch it real quickly here, just kind of see what it is that he did.
In 1910, Rutherford and his co-workers were studying
Okay, so that's kind of a visual example of Rutherford's alpha particle experiment. And basically what he discovered was that there was a positively charged particle in the center, in the nucleus of the atom. And the way he did this is he shot these alpha particles, which everybody knew was positively charged. And what he was expecting is that they would shoot right through this gold foil that he had, and nothing should deflect. It should go straight through and provide a stream all the way through. What he found was that some of them were deflected at sharp angles. And so now the question is, well, why? I did my experiment, it didn't quite turn out as I expected. Why? You know, what happened? What was different? Something's there to deflect them. And what he discovered, as he did multiple tests, was that there must be something to deflect it. Well, he knew what he was sending was positive. Well, what would deflect, or repel a positive? Well, like repels like. And so he theorized that there must be a positively charged particle in the atom. And he called it the proton because it's positive. And he determined that, well, okay, why do most of them go through and only some are deflected? Well, some are deflected because there's this positive particle, and so they're repelled. But most of them go through because most of the atom, most of the nucleus is empty space, and so they don't encounter anything to deflect them. It's only those that get close enough to the nucleus itself, and the nucleus being the center of the atom. That would be a good thing to know what we call it. Most of them don't even come close enough to that nucleus or where the proton is to be deflected. Most of them go through empty space. And so here's kind of a picture of his experiment. If you want to kind of look at it, you have the alpha particles passing through. Most of them pass straight on through, no problem. A few of them are deflected here and there. And the way he was able to tell that is he had this zinc sulfide screen, and it would flash whenever the particles struck it. And so he was the one that is responsible for determining and figuring out that, oh, there's another particle that makes up the atom, and it's located in the center. So he named that the nucleus. And it's a positively charged particle, and so we called it a proton. He also figured out that that particle was massively larger than the electron, that the electron was about 2,000 times smaller than this particle that's in the center, okay, called the proton. And so there was a massive difference, and we're going to kind of deal with that as we go on a little bit later. Now, there's one more particle that we have to discover, and we're going to do that tomorrow or on a later date, and deal with that one last particle to study. And then we're going to kind of revise our view of the atom. So far we know there's two particles, an electron and a proton, up to this point in time. So we have with Rutherford, the plum pudding model, and then here this one Thomson is the plum pudding model. With Rutherford, it's sometimes referred to as the nuclear model because he developed the nucleus. We're going to stop there today, and